BSD Now, episode 188, and then the murders began. We have a great show prepared for you, so stay with us for news about Dragonfly BSD, RaidZ performance, and a couple of new and great stuff you want to check out, so stay with us for your weekly dose of BSD Now. BSD Now, episode 188, recorded March 29, 2017. Hi, I'm your co-host Benedict Reuschling.
And I'm Alan Jude.
And we're having a great show prepared for you, so let's get right into it with the headlines of the week.
Yeah, the first one is...
So what do we have? Oh, Dragonfly BSD 4.8 is released. So I guess they have a bunch of new stuff prepared for the new release, so... What do they have, Alan?
They have EFI support in the installer, further speed improvements in the kernel, a new NVMe driver, which explains the NVMe benchmarks we did last week, a new eMMC driver, Intel video driver updates, and a lot more.
Ooh, wow. Yeah, that's a big one.
Yeah, they say this release further localizes cache lines and reduces and removes cache ping-ponging on all global variables. For bulk builds on many core and multi-socket systems, we see around a 5% improvement, and certain subsystems like the name cache lookups and execs see massive focus improvements. See the corresponding mailing list post for details. There's a link in the website. They also support eMMC booting, so you can actually boot from an eMMC device, as well as mobile and high-speed PCIe SSDs.
Oh, nice. So for people who want to switch to those, they can now run it with Dragonfly BSD.
Yep. They have better EFI support now, including in the installer. Numerous adjustments have been made to user-line utilities and the kernel to support EFI as a mainstream boot environment. The /boot file system may now be placed on either its own GPT slice or in a Dragonfly disk label inside of a BSD slice. Dragonfly by default creates a GPT slice for all Dragonfly and for all of Dragonfly and places a Dragonfly disk label inside of it so that you can have all your standard partitions, such as the disk names are roughly the same as they would have been on a legacy system, which is a much different approach than what FreeBSD did, but is interesting anyway. They have improved their i915 graphics stack is now up to Linux kernel 4.6, which means Broadwell and Skylake users will see improvements.
Nice.
They've also changed it, so their kernel is now built with -O2, so it's optimized 2 levels instead of, I think, 1 or none was the default before. That'll be interesting to see what that changes.
Performance-wise, yeah, or what other bugs might crept in just because they optimized too aggressively, but I guess they tested that before they put it into the release.
Yep. They updated their vkernel support to now do copy on write, so you can have multiple vkernels share one disk image. Their PowerD is now sensitive to time and temperature changes, and non-boot file system kernel modules can now be loaded from rc.conf instead of loader.conf, so they can be loaded when you have the smarter disk driver loaded.
Ah, interesting. Yes, okay, so you might want to check out the new Dragonfly BSD release.
They have the hashes and upgrade instructions are also included in the announcement. They also note that they've removed the OpenSSH HPN support from their SSHD. So watch out when you upgrade your SSHD that you don't have those couple of lines that are not valid anymore in the bottom of your config. They also have an exhaustive list of all the actual changes,
since 4.6 Dragonfly BSD?
Yeah, like refactoring the buffer cache code to remove dynamic KVA reservations and lots of other stuff if you want to get into the nitty-gritty of what changed.
Okay. Well, great. So check out your next release of Dragonfly BSD, and I see that you can also update that with git pull or fetch the origin, and then basically branch off and check out. Oh, nice. Okay, and then basically do your whole build world, build, install kernel cycle, make upgrade, and then upgrade your package as the last step.
Yep. So next we have a new commit to OpenZFS, or actually still a pull request. It's being reviewed. But bug number 8005, poor performance of 1 megabyte writes on certain RaidZ configurations.
So what's that all about? They found some performance regressions, basically?
So the way RaidZ works, it requires that space be allocated in multiples of p plus 1 sectors, where p is the level of parity. So with RaidZ 1, you have one level of parity, so 1 plus 1 is 2. So it means every time you do an allocation, you have to allocate 2 blocks at a time, or it must be divisible by 2. So if you have a file that takes up 3 blocks, and then, with your parity that's plus 1, it has to be divisible by 2. And, 3 data blocks plus a parity block is, so you're fine. Whereas if you had 4 blocks, a file that takes 4 blocks on the disk, plus 1 for parity means 5, you don't write out 5 blocks, you have to do 6. Otherwise, that 1 sector gap that you left there, or that would be left there if that got freed and a smaller file got written in that spot, means that that block would never be usable, because the smallest allocation is always going to be 2 blocks, right? 1 block of data and 1 of parity. And so you can't ever have a single block there. Or if you're using RaidZ 2, it has to be by 3, or RaidZ 4 has to be, or RaidZ 3 has to be 4. Otherwise, you end up with little blocks of fragmented space that you can never, ever use. So to make sure that doesn't happen, they have this padding. It says, thus blocks on a RaidZ 1 must be allocated in multiples of 2, and a RaidZ 2 must be in multiples of 3, and so on. And those are multiples of the sector size, so whether that's 512 bytes or 4K, depending on your disk. So to satisfy this constraint, the allocation size is rounded up to the proper multiple, resulting in up to 3 padding sectors at the end of a block. The contents of these pad sectors are not used at all, so we don't actually need to read or write the sectors, right? So if you actually have a 1 megabyte block and you're writing it, and the last 2 or 3 sectors are padding, you don't write them. You write almost a megabyte, not a whole megabyte. And you skip that little bit, because you don't need to waste time writing it. However, some storage hardware performs much worse, as bad as 50% slower, half as fast, so 100% slower, on mostly contiguous writes. So if you write 8 of these 1 megabyte blocks back to back to back, writing almost a megabyte and then skipping a little bit, and then writing almost a megabyte and skipping a little bit, is slower than just writing the whole megabyte. Yeah,
the whole thing out in total to the disk, or to the device.
So when you have those mostly contiguous writes where there's some small gaps of non-overwritten data between the writes, therefore ZFS creates optional ZIOs, which is the IO thing. It's like a bio on FreeBSD. When writing RaidZ blocks that include pad sectors. If writing a pad sector will fill the gap between 2 required writes, then we issue the optional ZIO and double the performance. So the reason this doesn't happen at 128K blocks is because if the amount we're going to write, if the gap is small enough that rounding up isn't going to make the block too big, we round up. But if you're doing 1 megabyte or larger blocks, that doesn't happen in ZFS currently because there's a limit. Right? So the problem is writing the optional ZIOs is done by aggregation code in the vdevq.c file. The problem is that it's also subject to the limit imposed by the size of an aggregation, or ZFS VDEV aggregation limit, which by default is 128 kilobytes. So that's why it works with 128K blocks. But when you do 1 meg blocks, any attempt to do an aggregation means it's over the max, and so it doesn't get done. So for a given block, if the amount of data plus the padding written to a leaf device exceeds the VDEV aggregation limit, the optional ZIO will not be written, and that results in the 2x performance degradation.
Which is bad,
So they detail the situations in which this can occur. The problem occurs only for certain values of A-shift, compressed block size, and RaidZ configuration. So it's really, it can be hard to predict when exactly this is going to happen to you. It cannot occur with a default record size of 128K because the aggregation default limit is 128K. If compression is enabled, all configurations with record size 1 meg or larger will likely be impacted because the compression will mean your blocks are never quite a megabyte, and they'll always end up with some number that might need some padding.
just when I wanted to increase my record size to 1 megabyte.
Yeah. Well,
okay.
with this fix, the problem goes away. So the problem notably occurs with record size 1 meg, compression off with 10 disks in a RaidZ 2 or 3 group with either 512 or 4K sectors. Therefore, this problem has been known as the 1 meg 10 wide RaidZ 2 problem. The problem also occurs with the following configurations. If you have a record size of 512K or 256K and compression is off, the problem occurs only in rarely used configurations of a 4 wide RaidZ 1, in which case you oftentimes want to just use 2 mirrors instead, or a 5 or 6 wide RaidZ 2. Although a 6 wide RaidZ 2 I use all the time, but not with a record size of 512 kilobytes. With record size,
that's very specific.
Yeah, with record size of 1 megabyte and compression turned off in 512 byte sector disks, it can happen with RaidZ 1 on 2 or 8 disks, or sorry, 4 or 8 disks, RaidZ 2 on 4, 8, or 10 disks, or RaidZ 3 on 3, 8, 9, or 10 disks. With 1 meg blocks on 4K sector disks, it happens on RaidZ 1 with 7 or 8 disks, which is fairly common because depending on a 2U chassis that's not all disks, 8 is the number of disks you get. So RaidZ 1 with 8 is relatively common. A RaidZ 2 with 4, 5, or 10 disks, or RaidZ 3 with 6, 9, or 10 disks. Also, if you use a record size of 2 megabytes or larger, although you have to change some kernel tunables to be able to go beyond 1 megabyte, many configurations are affected, including the higher number of disks, like even an 18-disk layout.
Okay, so that's the configurations where this problem may occur. So what's the workaround or solution?
So the solution is that we make the aggregations optional. The aggregation of optional ZIOs happen regardless of the aggregation size limit. So when we know it's just those couple of sectors between blocks, we decide to do it anyway. So basically, if we write a 1 meg block with nothing after it, we'll skip writing the optional stuff. But if we're writing a second block directly after it, we'll write those extra ones to allow us to just do one giant write instead of start, stop, which I think will also make a big difference for flash devices as well.
Yeah, because they have different writing patterns.
Yeah. So it says
in the future that's more coming into the limelight, into the focus of people running ZFS on these devices.
Yep. Okay. So as a workaround, until this fix is integrated in the OS you use, if you increase the size of the ZFS VDEV aggregation limit, there's a sysctl on FreeBSD under vfs.zfs. If you increase it to 256 kilobytes, it'll fix all commonly used configurations. Because then they won't run into that limit.
Sounds easy enough to fix.
But yeah, so this analysis was sponsored by Intel, who was wondering why this was happening. So here's a graph showing what it looked like before. And you can see that performance is going up as you add more disks, except for if you have 8 disks, then performance went way down. It's like, what's up with that?
Yeah, there's the gap in the middle.
Or RaidZ 2, it's like going up, then down, then way up when you don't have the problem, and then way down again when you do have the problem, and then way up when you don't have the problem. And RaidZ 3 is like ping pong, ping pong, ping pong. And you can see that only 7 disks or 11 disks, which are both the least common option, work with RaidZ 3. Everything else performed badly. Whereas when you look at it now with the fix, we see the performance keeps going up every time you add more disks.
Yep. Okay.
And it's all fixed.
Interesting problem indeed.
Yeah, and you can see that it basically is linear across when you have the same number of disks, right? You have to subtract 1 for each increased RAID level because that's the extra parity. But you can see that 3 disks in RaidZ 1 has the same performance as 4 disks, 8 disks in Z1 has the same performance as 9 disks in Z2, which has the same performance as 10 disks in Z3. And you can see that.
So that fix is already into the tree already?
No. So
ZFS,
currently
it's still discussed.
It's currently being discussed and analyzed and build tested. But expected to go to OpenZFS soon, and then quickly into FreeBSD after that. The change is not very big. However, if you're suffering from this today, you can work around it by changing a sysctl or whatever the equivalent to that is on Linux.
Yeah, the GitHub page describes that in detail.
Yes, but just that's a very nice commit message with all the details of
very
how it
thorough,
happens, when it happens.
Going into detail.
Yeah. But yeah, it turns out that this the gap filling performance improvement that caused the problem was introduced in July 2009. So it's been around a while.
Mm-hmm. Yeah, and people probably were wondering in the meantime, what's happening? Why is my performance so low in this
it depends on the device,
situation?
right? On some disks, not doing this might actually be slightly faster. But if you're writing a 1 meg block, skipping writing 8 or 12 kilobytes of data probably isn't making a difference. But for the devices that misbehave when you skip a bit, this makes them twice as fast. So yeah. Definitely worth having. But yeah, there's only one file changed, and it's only a couple of lines of diff here. 1, 2, 3, 4, 5 lines that aren't comments, plus a bunch of new comments, and then deleting a couple lines. So I expect this to go ahead quite soon, and then to be pulled into FreeBSD very quickly.
Well, that's good. So that's some things happening in the OpenZFS project with performance improvements or fixes of bugs. And yeah, we're looking to get that from the upstream OpenZFS repository. Great. So another story that we have for this week is, can you spot the OpenSSL vulnerability? And this one is basically, yes, you probably have guessed it, another not OpenBSD. Sorry, guys. OpenSSL, of course, spot vulnerabilities there.
Yes, this one's actually very minor. It's not a critical vulnerability or anything. I mostly picked this story because it shows how easy it is to make some of these mistakes, and it's just a good breakdown of it. So you can see here, this is some code that was added in OpenSSL 1.1.0D, which was released just a couple of days ago. It's in the server SSL code, which is SSL/statem/statem_server.c in the SSL bytes to cipher list function. And it can easily be reached remotely, so it, is a higher class of vulnerability, even though it's not a very major one at the moment. So you can see there's this loop there, right? You see the for loop at near the top. And it's for looping over the number of the raw length of the ciphers list, and then until the bytes remaining in the packet, and then it keeps going up by the cipher length. Yeah. So there's the for loop, and inside that for loop, there's an if statement. You can see if packet make sure that we can get at least 1 byte off the packet, and that the lead byte is 0, and we can get some bytes off the packet, at least an entire cipher off the packet, and then that we can go forward 1 cipher length. So there's a bunch of if statements that test a number of conditions. If any of these conditions fail, then the OpenSSL free here is called, right? And we free the pointer raw. But raw isn't the address of data that was allocated earlier. And you see with malloc, we malloc into raw, and then we set raw here into this other variable. But in the for loop, we increase the value of raw. So now we're freeing like halfway down the pointer or the memory region, not necessarily the memory region. So only if this if were to fail at the very first iteration would this ever do a correct free. Otherwise, we're freeing in the middle of the memory region.
Oops.
Yeah. So the fix was basically to switch raw here to this variable, the temp.ciphers_raw, which is a copy of the pointer when it was still the top of the memory region. But
the more complicated those for loops become, the more stuff you do in one single line that it's difficult to die. I have this a couple of times when students write too much in one line or try to do too much in one line, and I say, "Are you sure you know what you're doing? Just put it into multiple lines, then you will understand it better, and then you can put it back into one line.
Yeah.
So that's probably what's happening here.
But not quite. It turns out none of those checks in that if statement will ever actually fail. All these checks in the ifs,
they're always true.
Yes, they'll always be true, so not false. So you'll never go inside this if, because the if, you can see, is all negated with the exclamation marks.
Oh, not packet.
Yeah, so it's like, can I get a packet? Can I get, yeah. And so if any of these end up failing, you go inside the if. And if they don't fail, you pass over the if. Well, all three of these checks, it turns out, earlier in the code, we've already checked these things. Basically, so the earlier on in the function, there's a check that verifies that a packet contains at least 1 byte. So the packet get one function here is never going to fail because we've already checked that. Furthermore,
okay, so that's probably been written by different people who
possibly,
or at different times when they.
Furthermore, earlier in the function, it's been verified that the packet length is a multiple of 3. Therefore, the packet copy bytes and the packet forward are never going to fail either. Now, that's not to say we should remove those checks, because what if the checks up top change later? We it doesn't hurt to pedantically check that this hasn't happened. But it's mostly likely the reason why the memory corruption wasn't detected when we're freeing the wrong pointer, because we never actually execute that chunk of code. But having the extra checks there maybe isn't a bad thing, because if the checks up top were to change someday, we want to still enforce these requirements, right?
Yeah, the idea is good, but if you're not reaching that code or that condition is never met, then it's useful.
Then it raises the question, though, does this code do what the original author thought it did? Like, it seems the original author didn't think that those checks were already done. So while the code isn't necessarily wrong, is it actually doing what the person who wrote the code thinks it should do or expects it to do?
I guess never has anyone tested that specific part of the code.
Right. And also, what about the next person that modifies the code? Maybe changes or removes some of those earlier checks, and then all of a sudden one of these checks fails, and then it doesn't do what it expects.
Yeah.
But anyway, the author reported the bug and did a pull request, and that was accepted. And I have a link to GitHub here where you can actually see it being fixed, where they changed the free to free the right thing. So the author of this blog post here, Guido Vranken, says, P.S. I'm not posting this to ridicule the OpenSSL project or the programming skills. I just like reading code and finding corner cases that impact security, which is an effort that ultimately works to everyone's best interest. And I like to share what I find. Programming is a very difficult enterprise, and everybody makes mistakes.
Yeah, that's true. Even if you're a senior programmer, you're still prone to make mistakes like this or similar.
You can sit here and look at this code, and it looks like it all makes perfect sense. And then you realize, actually, because of this free isn't going to do the right thing.
Yeah, you have to step through with a test case or with a like a breakpoint, and finding the code paths that are being executed. Yep. Programming is hard, but people still do it. Yeah,
it's a good thing they do, or we wouldn't be.
As long as people find other people's mistakes and fix them, that's the good thing about the open source software world. Okay, good stuff here happening, and thanks to Guido for having a sharp eye on the code and submitting a fix for that for the open
and writing
SSL
a blog
folks.
post explaining it. A little fix like that would have probably gone unnoticed if he hadn't wrote the nice blog post explaining it. So this week's episode of BSD Now is brought to you by iXsystems. Go over to iXsystems.com/BSD Now and tell them what problem you're having, and they'll help you solve it. Get all the latest and greatest hardware and best in-class Intel processors, and build the server that suits your needs. The important one to remember
and if you're
is when you're sizing hardware, it's not about what the best performance you can get out of the hardware is. It's about the worst case. If you're designing a storage machine to back your VMware cluster or your virtualizer, whether it's Beehive or Zen or KVM or whatever, if you want to run a bunch of VMs off of it, you don't care what the most number of IOPS you can get out of the hardware is. You care that
because it's questionable when you will actually reach that
right.
IOPS. It's the question of what's the lowest number of IOPS you can definitely deliver.
You know, it's like I need at least this many IOPS for all my apps to work as fast as I need them to work. So I want to build hardware that has at least that plus some for me to run a couple more VMs in the future or whatever. And so designing it so that under the worst possible case, you can still get at least this many IOPS. That's the more challenging thing, right? You can't just look at, you know, the specs for the hardware and it says, oh, this is going to do 500,000 IOPS. It's like, well, that's great, but, you know, I need to know that I'm going to be able to get enough IOPS to run my VMs, even when the IOPS are not all linear reads. They're fully random and all over the place, and are mixed with more writes than reads because my VMs are all doing a lot of writing, and so on.
Yep.
So that's why it really pays to talk to someone that knows about hardware and knows about the open source stuff you're using, you know, be that BSD or ZFS or, you know, whatever. They know this stuff better than anybody. And, you know, they're definitely the people you want on your side when you're fighting these problems.
Designing your next server for open source. Or if you're thinking about running a new storage system, you can check out their TrueNAS, all flash and hybrid arrays, or their FreeNAS certified servers. They're also a nice pack of pre-configured storage that you can use, or look at their FreeNAS minis, which is also a nice thing for home users even. You don't have to have a big data center need. You can also have your FreeNAS mini under your desk and serving your private data files that you have or your
very
storage
popular
needs.
for media centers and backups. You got to keep those family photos backed up or they'll go away. You know, I still think it's a couple of years ago now, but iX had a blog post about, you know, a single flip bit in a JPEG and what that does to your family photos. And it just shows
if it can be read at all after that.
It's flip. Like you can see part of Matt's face, and then everything after that is just all green in blocks and terrible. And it's like,
not very
that awesome
anymore.
family photo is now gone. It's like, oh, turns out ZFS saved it. It's okay.
Yeah. So it's in most of these ZFS storage systems that they are building for you, and that you can combine with them and to find the best solutions for your specific needs in the server space.
Yep. Okay, next story. I found a really interesting article about research debt, and I thought, you know, it applies to OS development, whether that's research into it or the actual application of it. But I found it really interesting. So it says, achieving a research level understanding of most topics is like climbing a mountain. Aspiring researchers must struggle to understand vast bodies of work that came before them to learn techniques and gain intuition. Upon reaching the top of the mountain, the new researcher can then begin doing novel work and throwing new stones on top of the mountain and making it a little taller for whomever comes next.
Right. I get this in the university. So I'm moving a little bit more into the phase where I help students with their thesis, like their bachelor thesis or their master's. And the problems that they mostly have is, up to that point, they mostly had like lectures and they learned pretty much the stuff that they needed to do. But when they do their thesis, they're doing new stuff, which no one has covered before or not that much. And they sometimes struggle to find the right approaches, like how to do the research properly and how to do these information gathering or how to do the experiments properly. And that's important for them to know. And I guess this article also covers a couple of these points.
So they say, people expect the climb up the mountain to be hard. It reflects the tremendous progress and cumulative effort that have gone into the research. The climb is seen as an intellectual pilgrimage. The labor is a rite of passage. But the climb doesn't need to be massive, the climb could be massively easier. It's entirely possible to build paths and staircases into these mountains. The climb isn't something to be proud of. The climb isn't progress. The climb is a mountain of debt.
Okay, the climb is all there is. If that's a nice Game of Thrones reference here.
So programmers talk about technical debt. You know, there are ways to write software that it's faster in the short run, but could be problematic in the long run, right? We all know about that. And, you know, there's institutional debt and other types of the same kind of idea. But they kind of break down some of the different aspects of it and explain what they are. So the first is poor exposition. often there's not a very good explanation of the important ideas, and one has to struggle to understand them, right? The problem is so pervasive that we take it for granted and don't appreciate how much better things could be, right?
Yeah, because we didn't see the other side, or how
it's
how
never
things
been
could
easy,
be.
so we don't realize how easy it could be. So having good explanations and documentation on how stuff works helps people get up to speed faster, so that they can do something, they can expand on the research or the system or the function or whatever and make it even better.
Try different approaches.
Yeah. So while it does take some time to craft that explanation, the value of that can be it can be a multiplier as far as getting more work done in the future. Then there's undigested ideas. Most ideas start off rough and are hard to understand. They become radically easier as we polish them, developing the right analogies, language, and ways of thinking about the idea. But some ideas never leave that rough idea stage. And so it's harder for people to, understand all of that, to build on it, when even necessarily the original person hasn't thought of it that way yet. And they have to spend all this work just to understand how it works in order to then try to build on it. Whereas if the polish had already been there and they had a good explanation, they could have just started building on top of it much sooner.
Yeah. So build the stepping stones for the people to climb onto the next level.
But bad abstractions and notation. Abstractions and notation are the user interface of research. They shape how we think and communicate. Unfortunately, we often get stuck with the first formalisms that were ever developed, and they might be bad, right? Just because it was the original way the first paper talked about it doesn't mean it's the right, abstraction or notation or analogy.
Yeah, it's not written in stone. Yeah.
For example, the concept that objects with extra electrons are always negative, or that pi is wrong. But there's also noise. Being a researcher is like standing in the middle of a construction site. Countless papers scream for your attention, and there's no way to filter or summarize them. We think noise is the main way experts experience research debt. Because people are expected to be so prolific and write so many papers as they do academic type research, you end up with all of these papers, and it takes a lot to read and understand them all.
Yeah, and to keep track of them. I guess it was more. It's even more difficult now that we have the internet and the worldwide exposure to all these research facilities and universities than a couple of years ago, when the internet wasn't so prominently available. So people just had a library to research. But now on the internet, everything's out there, and you probably should make sure that you find all these papers that are dealing with the research that's happening in your area.
Yep.
Or the research area.
Yeah, so say, clear thinking. It's worth being clear that research debt isn't just about ideas not being explained well. It's a lack of digested ideas, or at least a lack of public versions of ideas being digested. It's a communal messiness of thought. Developing a good abstraction, notation, visualization, and so forth is improving the user interface for that idea. This helps both with understanding ideas for the first time and with thinking clearly about them, even if you've known about it for a while, right? Conversely, if we can't explain an idea well, that's often a sign that we don't understand it as well as we think we could. It shouldn't be a surprise that these two things largely go hand in hand. Part of thinking is having a conversation with ourselves.
Yeah. It's a good thing when you teach that you find yourself thinking about, did I really understand that topic that I'm teaching? And teaching gives you also the feedback from the learners that I didn't understand that well. And then you think about, I also didn't understand some specific aspect of that. And that keeps your brain working on trying to get really deep into that specific subject that you're teaching.
So it says there are trade-offs between the energy put into explaining an idea and the energy needed to understand an idea. On one extreme, the explainer can painstakingly craft a beautiful explanation, leading their audience to understanding without even realizing it could have been difficult. On the other extreme, the explainer can do an absolute minimum and abandon their audience to struggle. This energy is called interpretive labor. So they propose the idea of research distillation. in particular, it's not something that many people do. So research distillation is the opposite of research debt. It can be incredibly satisfying, combining deep scientific understanding, empathy, and design to do justice to our research and lay bare beautiful insights. Distillation is also hard. It's tempting to think of explaining an idea as just putting a layer of polish on it, but good explanations often involve transforming the idea. This kind of refinement is an idea that can take just as much effort and deep understanding of the initial discovery, right? Actually taking an original idea and turning it into something usable can be just as much work as inventing the original idea in the first place.
Yeah, and there might be setbacks and false starts and all these things that.
Well, in particular, the distillation can often require an entirely different set of skills than the original creation of the idea. So, expecting one person to do both parts doesn't necessarily make sense, because the person that came up with the system or the idea and built the code for it isn't necessarily the right person to polish the idea and make it into something that everyone can understand and use. Yeah. Almost all of the BSD projects have some great idea or subsystem that just needs the distillation into an easy to understand and use platform or tool.
That's why these conferences are so important, because then you can present your idea to other people who have different viewpoints and ideas about it.
By trying to explain the idea to someone in person, you can improve the explanation of it and help expand the knowledge base. And yeah, exactly. We can pass this information along and try to help other people up the mountain.
Yeah.
But they say, part of the problem is that, we don't really have research grants for people to do research distillation, to take a series of papers on an idea and, clean it up and make it into one thing that explains the whole concept, which would help lots of, all future research in that area could benefit from having that. But it's not the sexy thing. It's not what people are looking to do.
Yeah,
it's not where there's funding to pay someone to do it.
It's not incentivized.
Yeah. So, it says, where are the distillers? And it says, like the theoreticians, the experimentalists, or the research engineer, the research distiller is an integral role into a healthy research community. Right now, almost no one is filling that. Partly because, there are no research grants for just rehashing other people's ideas into a more usable form.
Yeah.
Maybe there should be. And so then they go on to talk about trying to create an ecosystem for distillation, including maybe a journal that just consists of distillations of batches of papers, or a distillation prize for, helping come up with a better explanation of what machine learning is or whatever. A distill infrastructure, tools for making ideas more accessible in interactive ways. Anyway, they have lots more there and a whole bunch of recommended future reading. If you're interested in this idea, then it's definitely worth checking it.
And we're back with our news roundup for this week. And the first one is from Michael W. Lucas, called "And Then the Murders Began."
Yeah. So he says, a whole bunch of people have pointed me to an article, and he provides a link, which claims that you can improve almost any book by making the second sentence "and then the murders began." So basically taking the first sentence of the book and adding that to the end of it. He says, it's entirely possible that they're correct. So he says, let's check. So he grabbed all of the books he's written with a sampling of the books and trying it. So it's really interesting to see what happens when you add this to some random tech books.
So the first one is a Cisco Routers book, and that one starts with "Welcome to Cisco Routers for the Desperate," and then the murders begin.
That one's...
Well, it gets better.
Yeah.
It gets better.
I don't know. The GPG one's kind of funny. It's like, many people find encryption disturbing and even a little scary. And then the murders began.
Over the last 10 years, OpenSSH has become the standard tool for remote management of Unix-like systems and many network devices. And then the murders began. And of course, the book that you and Michael Lucas wrote, the Z file system, or ZFS, is a complicated beast, but it is also the most powerful tool in the sysadmin's Batman-esque utility belt. And then the murders began.
I thought Batman wasn't about murdering people.
Yeah, last time I checked, that was a different, kind of thing. And the new book that is coming out, he provided the very first sentence for Absolute FreeBSD, 3rd edition, which goes, "Blood shall rain from the sky, and great shall be the lamentation of the Linux fans. And then the murders will begin." And in the spirit of that, I provided another book in the BSD community that's hopefully well known, which is the design and implementation of the FreeBSD operating system.
Ooh.
And there is, of course, also a very first sentence here in Chapter 1, History and Goals, which goes like this. History of the Unix system. The Unix system has been in wide use for over 40 years and has helped to define many areas of computing. And then the murders began.
Which actually leads into another announcement. Michael Lucas's new book, Git Commit Murder, recently came out, and I've been reading it. But it's basically about a parallel universe in which there's a conference called BSD North that takes place at Byword University. If you've been to BSD Can in Ottawa, you get the joke there.
There will be
there's a murder mystery, and someone many of you know maybe gets murdered, and it seems very interesting.
So it's
far.
Agatha Christie.
Yeah, so it's Agatha Christie if she used Unix.
Okay.
But if you've been to any
non-tech novels?
Yeah, but if you've been to any kind of open source conference, whether it's BSD or Linux or anything like that, you'll recognize the archetypes of the people and the setting and the feelings and all the stuff, and it's very interesting. I'm on like about 30-something% away through the book, according to the little progress bar at the bottom of my Kindle.
Okay, yeah, check that out. It's the newest book from Michael W. Lucas, our famous BSD and favorite author. Okay, so yeah, whenever you want to spice up a text, add "and then the murders began" to it. The next item is about DistroWatch Weekly reviews RasBSD.
First,
sorry.
we have our next sponsor, DigitalOcean. If you need to run something on BSD, like I know I got to get Benedict set up with a Quasel core so he can stay on IRC.
One of these days, yeah.
So
real soon now.
Well, you could be done in the time we take to talk about it here. You just go to DigitalOcean, you click this little sign up button, you enter your details, you go in there, make sure you put in the coupon code FreeBSD Now, and they'll add $10 credit to your account. Although you still have to make the initial payment to, prove you're not a scammer. But then you can spin up that $5 droplet. You get FreeBSD, whichever version you want, 10.3 or 11 with UFS or ZFS. Get that spun up, log in within 55 seconds of creating the VM or of hitting create, your VM's up and running. You log into it and you just package install Quasel Core and you'll be done.
Okay.
So
so
get to it.
When I get this, I will report about how my experience was, and I guess it will be a nice one because they have a lot of experience in creating these droplets and running your favorite BSD system in their cloud.
So the other question is, where are you going to put it?
Yeah, which data center? Yeah, they have a couple of available throughout the world.
Yeah, they have San Francisco, Toronto, New York, London, Amsterdam, Frankfurt, Bangalore, and Singapore.
Yeah, so most big cities of the world and distributed globally.
Yep.
So
and they also have a speed test tool. So if you go to their networking page and click on a data center, you can actually run a speed test and see which one maybe has the best performance to your house if you're worried about downloading stuff or uploading stuff to the thing. If you really think after, say, that recent law being passed in the US about ISPs selling your private data, if you decide you really want to use a VPN, doing it off a droplet you control maybe gives you a little better safety margins than just using some generic VPN service. Although it obviously doesn't provide more anonymity because that droplet is tied to your credit card and so on. But it means that you know that nothing's in between you and the VPN and that nothing hinky is happening on the VPN side. And you can decide whether you want it to be somewhere close to you in order to get the best performance, or if you want to terminate your traffic in a different country.
So that's something you might want to check out when you are considering going on DigitalOcean.
So next story we have is Netdata now supports FreeBSD.
Yep. So what Netdata is a monitoring tool which provides you with live data about your system that you're running. And the best way to describe it is showing the demos that they have. So they have a couple of demo systems running on their machines, and you can see that there's stuff happening because the graphs are moving, and you can zoom out and get a lot of different metrics like CPU, memory, load, disk I/O, and all these things. And that one is now also available for FreeBSD, so you can get your FreeBSD monitoring metrics.
Yeah, I saw a tweet come out to me on Twitter when they were starting to work on this. They needed to know how to get certain data out of FreeBSD. And they knew how to do it on Linux with /proc, and I provided some advice on how to use sysctl to get the same data out of ZFS and so on FreeBSD.
Yeah, so that's great. So you can get a lot of metrics from your live system. If you just want to see what's happening on your machine, then look at your Netdata output and get a quick glimpse of what's happening on your machine. So yeah, check that out. It should be on the FreeBSD ports as a package or as a port itself already.
Cool.
And yeah, test it on your systems. And if you haven't used it already, check out the demo sites and give it a whirl.
Yep.
So now we're getting into the DistroWatch article. Okay. So this one, so DistroWatch is basically a site that covers all the various distributions of Unix or mostly Linux that are out there, but also the BSDs. And they have a weekly summary or like a news section. And this one has a feature story by Jesse Smith about RasBSD. So for those of you who don't know, RasBSD is a FreeBSD-based project which strives to create a custom build of FreeBSD for a single board and hobbyist computers. And Raspberry basically takes a recent snapshot of the FreeBSD system that they provide on their website and adds an additional components like LXDE, desktop, and a few graphical applications so you can run something on your embedded board like a Raspberry Pi. And the Raspberry project currently has live images for Raspberry Pi devices, Banana Pi, Pine64, and BeagleBone Black and Green computers.
Yeah, so it's basically FreeBSD with some of the stuff already set up so that you can have graphics and so on your SPC.
And so from the review, they said that it's kind of a tongue twister. RasBSD system is quite minimal, running a mere 16 processes when the tester was logged in. So not much is running in by default. And in the background, the operating system runs cron, OpenSSH, syslog, and the PowerD power management service. Other than that, the user shell and terminals, nothing else is running. This means that RasBSD uses very little memory, which is important on these embedded devices, requiring just a mere 16 megabyte of active memory and 31 megabytes of wired or kernel memory. And he goes on to write that he made a note of a few practical differences between RasBSD and the Pi versus one of the Raspbian operating systems, which are more usually used. And one of the major or minor differences is RasBSD turns off the Pi's external power light after the boot has happened, and Raspbian leaves the light on. So this means that when you are running on RasBSD, you save a little bit power by not running this little LED on your device.
That LED is exposed by a dev LED, so you could turn it back on if you really wanted.
Yeah, if you really want to have that, then there's a way to switch that on. But by default, it's not running after you have finished booting and are logging into your device. And it concludes with basically, apart from these little differences, there are a couple of them, you can find them in the article itself. Running RasBSD on the Pi was a very similar experience to running Raspbian. And the time that the operating system was running was pleasantly trouble-free, which is expected of a BSD system. if I might add that. Long term, the reviewer thinks that applying source updates to the base system might be tedious and SD disk operations were slow. However, the Pi usually is not utilized for its speed, but rather its low cost and power energy usage. So people who are looking for a small home server or very minimal desktop box, RasBSD running on the Pi should be suitable.
This is one of the reasons why Brad Davis, who's behind the RasBSD project, is pushing for the package-based stuff, because it'll allow it to work. Because of the way FreeBSD update works, even if there were builds for the Raspberry Pi, it wouldn't be very useful, because having to read all the files off, run the SHA-256 of them, and then compare it, and then write new files, and then do binary diffs, would, because of the speed of an SD card, would take a very, very, very long time. So a package-based system that can reduce the amount of files that have to be written and just overwrite them in place instead of having to read, compare, patch, write, should be much more performant on the Raspberry Pi type devices. So yes, hopefully we'll have package-based soon, and that will ameliorate that problem on the Raspberry Pi type devices.
Yep. And in the meantime, check out the RasBSD project at rasbsd.org. And while you're doing that, and if you like it, thank Brad Davis for his work on that distribution.
So our next story is a statement about Research Unix, 8th, 9th, and 10th edition.
Oh, okay. That's quite old already.
Yes.
But yeah, nonetheless.
But these are bits of Unix after BSD forked off, basically, that have always been under a commercial license not available to people. Alcatel-Lucent of the US, on behalf of itself and Nokia Bell Laboratories, agrees, to the extent of its ability to do so, that it will not assert its copyright rights with respects to any non-commercial copying, distribution, performance, display, or creation of derivative works of Research Unix editions 8, 9, and 10. The foregoing does not transfer ownership of or relinquish any intellectual property rights, including patent rights, of Nokia Corporation, Alcatel-Lucent, or their affiliates. It does not grant a license to any patent application, or trademark of Nokia or Alcatel-Lucent or its affiliates, and it does not grant any third-party rights or licenses, or grant any rights for commercial purposes. Neither Alcatel-Lucent nor Nokia Labs or Nokia Bell Labs will furnish or provide support for Research Unix Edition 8, 9, and 10, and makes no warranty or representation hereunder, including but not limited to any warranty or representation that Research Unix Editions 8, 9, and 10 does not infringe any third-party intellectual property rights, or that Research Unix 8, 9, and 10 is fit for any particular purpose.
So that's the usual legal text that you
but
might
basically,
see on these.
it means that you can now have access to Research Unix editions 8, 9, and 10 under a no commercial use license. Some very interesting reading.
Yeah, and I guess people will start compare versions now, and what kind of changes went into this version and that one, and what kind of code came out of that, and how Unix diverged into these different distributions, or where it ended up in different products or software stacks. So yeah, that would be interesting to check out further. It's I guess a lot of code to look through, but nonetheless,
I think this will
worth looking into.
Make some of the BSD history projects interesting.
For the researchers and historians who want to dig deep into how everything came to be SD. And here are your weekly BSD bits for this week. So the first thing is the BSD family tree. Have you checked this out before?
Yes,
because
I've seen this
getting
before.
Continually upgraded with the newer releases that are coming out.
Yeah, so it kind of relates interestingly to the recent story we just covered. So you can see how there's first, second, third, fourth, and fifth edition Unix. And then in sixth edition, they started and made one BSD. And from that, they made two BSD. And this was for the VAX, if I remember correctly. And then it splits off, and you see the later versions of that. But then from 7th edition Unix and 32V Unix, you eventually get 3BSD. and from that, FreeBSD. And then 4.1 BSD actually merged stuff into 2.8 BSD. And 4.1a became 2. And 4.1c became 2.9 BSD, and so on. And then over here, you can see you have 8th edition Unix, which is after Unix wasn't really available to us anymore. And you can see that code went from 4.2 and 4.3 BSD into 8th and 9th edition, but not the other way. And then you see 4.3 Tahoe, which I think was one of the first ones with TCP/IP. And then the other one here is 10th edition. So you see 8th, 9th, and 10th edition were, well before 4.4 BSD or 386 BSD, where most of the history that we know about really gets going. Although the other interesting thing is there are still BSDs you can get today based on the 2.x BSDs for the little PIC microcontrollers and so on. And that's Light BSD, I think, something like that. And then there's Retro BSD, which is based on, I think, 4.2 or 4.4 BSD.
Yep, to keep that line going on.
Yep, and you can see you get 386 BSD, which interestingly, 386 BSD 2.0 was also recently dropped on GitHub for people to look at. Okay. 20 years after.
After the fact, after it happened.
But you can see 386 BSD eventually made it into FreeBSD 1.0, and then 4.3 BSD net/2 plus some stuff from 386 BSD is what became NetBSD 0.8 originally. And then you see the FreeBSD is coming from that, and then 4.4 BSD Lite was the version after the removal of the AT&T files from the lawsuit, and that resulted in NetBSD 1.0 and FreeBSD 2.0 and BSD OS, which was the commercial BSD OS. And then going down from that, you can see there's something called RasBSD, and then you also get NetBSD 1.3, OpenBSD, and FreeBSD, your NetBSDs. And there's when OpenBSD kind of forked from NetBSD, and then you can see the various lineages of FreeBSD 2, 3, NetBSD, OpenBSD, on and on. There's the 4s. You can see FreeBSD 4.4 is what became macOS 10.2. And then you can see the fork from FreeBSD 4.8 making Dragonfly.
Oh, yeah.
macOS 10.4 being based on FreeBSD 5.1. You can see where FreeBSD 6 came from, and then how that relates to, FreeBSD 6.2 happened around the same time as NetBSD 3.1, OpenBSD 4.1, and Dragonfly 1.8. And then going on.
I like the ASCII art of all these like crossovers and merging and splitting off again.
This took a lot of time to white space all this properly. But you can see FreeBSD 9 and 10, and then there's 11 being branched, and soon there'll be 11.1 under here. And you can see OS 10.
And for those who are very picky about, this happened at this specific date, there's a time tolerance section here mentioning that plus minus 6 months, depending on which book article you read. If it was the announcement in Usenet or if it was available as tape, then they will have it there. So there's a little bit of, time difference.
And then there's a thing at the end here where it shows the source where they got the date. We see that Multics was created in 1965, and then Unix was in the summer of 1969 for the DEC PDP-7. Then we see first edition Unix was November 3rd, 1971, and they say they got that information from a book called Quarter Century of Unix, and so on. So they actually have their sources and cross-references where they got the data from.
Yeah, some of these books might still not be in print anymore. So
in 30 or 40 years.
Get even those. So it's good to have a common source where people can put in historic Unix information into a repository if they know where some specific historic Unix version
you can see Dragonfly BSD being updated just 2 days ago. Its release noted here.
Yeah, so this will be updated by people as Unix evolves. And basically Unix evolves every day by people making changes to it and applying patches.
But just considering the fact that it's basically changed every day since 1970, and it's 2017.
Yeah, that's
try to think about that for a minute.
Very long period, and it's still ongoing. That's part of the reason why Unix is still very interesting as an operating system, because it also has Unix history in it, but it's computer history, like porting to all these different platforms and systems that were part of the computer history as well. So all these were not part of Unix, but they were with Unix and evolved with Unix. And yeah, that's a very interesting thing to see over time, how the history of computing became also Unix history.
So the next story we have is a Unix permissions calculator. This can help you understand how these numbers seem like magic sometimes, but it's just octal. So read is a 4, write is a 2. So if you add read and write together, you get a 6. And then execute is a 1. So if you add it, you get 7. So it means if you want read and execute but not write, that'd be 4 plus 1 is 5. And then
that's a good teaching tool, actually.
Each of these columns is just, the first one, the least significant one is other. The next one is group. The next one is the user or the owner of the file. And the last one is special, where you have set UID, which means that when you run this binary, you don't run it as your user, you run it as the person who owns the file, or the same for the group. And then there's the sticky bit, which is mostly used for directories. It means keep the same permissions and so on. Although they also have little toolboxes that can tooltips that explain how these work and what they're for.
Yep.
Also, each of these has a character specified with them. So you don't necessarily have to remember the numbers anymore. You can use symbolic mode. So if you want to take a current permission and add read and write for the user, you can just type U for the user plus RW, and it will add the read and write flags to the user. Or you can say do it with the group. Or you can mix the two. You can do user plus read, comma, group plus write, or whatever you want to do.
Yeah.
The other advantage to this is it's cumulative. So it can take what the permissions currently are and then modify them by adding and removing stuff, rather than just overwriting the current permissions with different permissions, which can be very handy when you're doing, say, a recursive operation on a whole bunch of files. It's like some of these files are executable and some of them are not. I don't want to modify that. I just want to make it so that the person who owns it can write to the files. So I just use user plus W, right? Whereas if I chmodded 0200 on all the files, that would be bad because no one would be able to read them anymore. But by doing this relative operation, you can add the write without modifying any of the other settings they happen to have.
Yep.
Yeah,
so
that's definitely an interesting teaching tool.
Yeah. So if you cannot remember those and it hasn't been part of your muscle memory for a while now, then this is a good way of learning these and trying out the different combinations. There are also code examples in case you want to do change mod with PHP or other programming language like Python and Ruby. There are some code examples that you can directly use.
Yep. There's also this decode octal one where you can type in an octal and it will break it down into what the actual flags are. So yeah, this is definitely a very interesting teaching tool.
Yeah, so check that out if you want to know more about Unix permissions that you don't know already.
Next up, we have the release of NAS for free for x86 version 11.0.0.4.4141.
Okay, they might get to a little bit more versioning.
Well,
deeper and deeper.
I think the reason they do that is the 11.0 part at the beginning is the FreeBSD version.
Yeah, right.
And then I think the next .0 is the patch level from FreeBSD, and then after that is where they get into their version numbers. And then I think the last one is just their, version control revision number.
So that's a bug fix release, or are there new features in there?
Well, it doesn't really say. The changelog is a bit scarce. But all right, update notes. That's for if you're upgrading. It doesn't really. They upgraded the version of Samba and a couple other things.
Yeah, apparently 32-bit users are not receiving any more updates in the future because there's a upgrading node that they might want to switch to i386 not anymore in the future, so they will be 64-bit. They list the minimum system requirements that's needed for the update and some of the things that people will probably encounter. There's a change list right at the bottom.
Mostly updating packages and security fixes for FreeBSD.
So you get newer versions and some fixes in packages and ports, and a couple of performance improvements and some other smaller updates. So yeah, check that out. If you have a NAS for free running, then you might probably want to update to the latest version.
So next, we have the latest edition of BSD Magazine, where they have a simple quorum driver for the FreeBSD CAM target layer high availability and the Beast storage system.
Oh, okay.
Plus some interviews and some security features of OpenBSD and lots of other interesting bits.
And that one is free to download? Okay, so if you want to get some more reading done in the BSD world, then check out the BSD Magazine, the newest one that just came out. And last but not least, there is a new version of OPNsense, 17.1.4. So that one has a link to their forums that lists all the patch notes here.
Yep, they switched their installer around to a simpler config importer. They no longer set shell privileges every time you do a password reset. Lots of other changes in here.
Big and small, IPsec, OpenVPN, source and ports updates, plugins got updates.
Excluding an IP address from the traffic shaper if you're using a 3G or 4G modem. They've applied the hardened BSD SafeStack stuff to all their base applications and updated a bunch of ports.
Yeah, so there's a lot of new stuff happening lately in all the projects. And yeah, I guess there's also a lot of, cross-pollination going on with fixes and patches going back and forth.
Yep.
Which is good. So yeah, check out the latest release of OPNsense.
And this week's episode was also brought to you by Tarsnap. Go to tarsnap.com/BSD now and start doing your backups. You're really going to regret it if you don't back your stuff. It's getting to be tax time of the year. You want to make sure you back up those documents that you're legally required to keep for many years.
Without anyone else looking at them except you, because you're the person who is holding the keys to that.
Yeah. In the end, you generally need to keep those tax documents around longer than the life of a hard drive. And so you probably want to keep them somewhere safe.
Yeah. And the longer you can access them, the better it is. And you can rest assured that only you can access those because they are encrypted on Tarsnap's storage.
Yeah, well, so they're encrypted on your computer and then sent to Tarsnap storage. And that's the important part. The other thing is that it does the deduplication and compression on your side before it encrypts them. And this is important because when they do deduplication on their side, it means they have access to your raw data. And more importantly, they can tell which files you have if somebody else happens to maybe have those files as well. So it can see, oh, look, these two people have the same file. I wonder if they're related or something, right? Whereas, when you deduplicate it, compress it, and then encrypt it on your computer, all they see is random data, and they can't make any inferences about it at all. And that's important if you're worried about your privacy or if you're paranoid. Because Tarsnap, backups for the truly paranoid.
Right.
And with a price of only 25 cents per gigabyte per month, or 250 pico dollars per byte month, if you want to be scientific about it, means that because of deduplication, you can store a lot of data for not a lot of money. Yeah,
and it's available beside the BSDs on Linux, Debians, the Red Hats, the Gentus of this world, Arch Linux, Alpine, Slackware, NixOS, and other Linux distributions, as well as Mac OS X and Windows subsystems for Linux.
Yep.
So a lot of available systems that you can run it on. And there's also the source code, which is platform neutral, available as well on the website.
Yes. And if you, it's designed to have a tar-like interface. So if you've ever used the tar command, you can use Tarsnap. But if you want more help, Michael W. Lucas does have an entire book about how to use Tarsnap, including setting up your backup regime and dealing with restores and all the other considerations and stuff that go with it. Making sure that you can recover your key in lots of scenarios and so on.
Right. And if you want to listen to what other people are saying about Tarsnap, then check out their testimonials page about people that are using Tarsnap for their backup needs.
Yes. Big interesting one for me was that the company that processes all the credit cards for my business uses Tarsnap, and that makes me feel good.
Yeah, you sleep a little bit better at night knowing that they use that service.
Okay. So for feedback, again, because we're recording early and because you, the audience, have failed in your duty to send us emails, we have a tweet that came in as our feedback this week. So Gozes writes in and asks BSD Now, he says, episode idea, a guide for developers to help find a mentor, get involved, and contribute to FreeBSD.
Yeah, and we have some experience with that. So, of course, Alan and I were already a couple of years into the project, but we also started somewhere. It didn't fall from the heaven.
I didn't get my first commit bit till 2014. You gave it to me live on an episode of BSD Now, so I'd already been doing BSD Now before I had a commit bit.
Yeah.
So, I've been through this whole process during the show.
Yeah, so it takes some time to get into it. But if you're really engaged and want to do that, there are ways to get involved with the project, of course. So the first thing is that you can submit bugs for it or look at the bug system yourself and work on some of the bugs, provide patches for it, even if it's a doc bug or something that you found in ports, or if you have ported a port yourself via the porter's handbook. You can also submit that as a bug report, and someone will pick it up.
I know that Brian Callahan teaches a class once a semester on how to contribute to open source. And as part of that class, the 20 or 30 students have to go through a BSD of their choice, check out the source code repository, find a mistake in the documentation or the code, although they usually just do documentation because it's only a one-day class, or this particular project is a one-day thing. So they check out the documentation for the website or the handbook or whatever, find a problem somewhere, and they have to fix it, create a patch, and submit the patch via the bug tracking system. I know Dan's given a tutorial like this at conferences before as well.
Yep.
But it's a fairly straightforward process. There's some documentation on how to do it, and we're constantly making that better. Of course, the people who can do the best job of making documentation on how to do your first commit are people who are just doing or just finished their first commit. As you know, Benedict and I worked with Michael Dexter as he was going through his first couple of commits in Tokyo. So yeah.
Yeah, there were some things that weren't as easy to understand for newcomers, so we're trying to improve that document as well.
But in general, the way to get started is to find some problem somewhere and work on fixing it, whether it's just improving the documentation, adding new documentation that isn't there, or fixing a bug or adding a flag or a feature or whatever, and submit that patch through Bugzilla and or Fabricator, now that we have that, reviews.freebsd.org. And once you've done that a couple of times, you'll basically annoy someone into punishing you.
You draw attention, yeah. So there will be people looking out for people to mentor, and it's usually someone who's working in the same area. So let's say you're doing changes in the network area, then networking people will see your changes, and the more changes you do, the more attention it might draw. And then those people will approach you. Either they send you an email or contact you on IRC and asking you, hey, would you be interested in a mentorship of FreeBSD? So that's how it usually goes.
Yeah. So if you submit the change via the FreeBSD review system, reviews.freebsd.org, when you submit one, you don't have to set any reviewers. It will add a group. If you're not a committer, it'll add a group of committers interested in helping people with their first couple patches, kind of thing. But if there's someone identified as a maintainer or someone that's active in the area we're working, it's good to add them as well. And then, as the last effort, you can add me specifically, and I will try to help you find the right people to review your code, rather than, I'm not a great code reviewer, but there are many other good ones. And we can help you kind of get going. And after you've done 5 or 6, you likely will be punished.
So
as part of that,
there are some things that you can do towards that.
We're working on making the process easier. We'd love feedback on that as well. If you tell us where you're getting caught up and where you're feeling like things aren't happening for you, we can try to help smooth that out. All of the BSD projects could do a better job of providing constructive feedback and helping people along. It can often feel like you're being ignored. It's just, it's not that so much as that, all of us are very busy and we only have so much time to work on FreeBSD, but...
Right. So patience is required. And so one thing that you shouldn't do is try to nag people. Hey, there's this patch on the bug tracker.
Well, you do
look
need
at
to
look at it.
Yes, but you do need to try to bring attention to it sometimes. But yeah, it's hard to balance not being annoying about it at the same time. But we're in this catch-22 of we only have so many people and they're all busy. But because of that, we're not bringing in enough new people to solve the problem. So we want more people involved, and even small things can add up over time to get more. I mean, even I started out with a couple of small patches, and it became more and more as I became more confident with working with the system and doing these changes to the documentation in my case. And now he's on the core team.
You shouldn't be disheartened if you only provide a small bit to an improvement or to a fix.
And now he's on the core team, and he's a vice president of the FreeBSD Foundation. And he's an army of mentees.
Over the years, it's a very interesting career,
when I started,
if you want to call it
even when I started, it was, I'm going to write some documentation for ZFS because it's really cool and more people should know about it. And I've used it a bit, so I can write a little bit about it. And, I was just a sysadmin. I didn't have any programming background at all. But eventually I learned a bit of C because I wanted to make some tools to do more things with my shell scripts. And eventually that turned into, this should be simple enough. I can make the small change of the bootloader to draw a menu of ZFS boot environments. And then that turned into, I can make it support encryption somehow. And then it's like, I can add new things to ZFS. I'm like, what? That's me? I'm not the same person anymore. But,
and now people are asking Alan for, how do I do this in ZFS? And it's a very interesting thing. After a couple of years, you see that a certain person suddenly becomes the expert in a certain area that they were originally also a newbie to begin with.
So even the small things to get started with are great. You don't have to do something big to start with. Although if you have something big, bring it. But
other things you can approach us or get involved is to go to conferences. Usually the conference has a way for, like, if you're a student, to get a discount for the conference entry fee, or if you are a person that are struggling a little bit with the financial part, you can also ask the foundation for a travel grant to your first BSD conferences by describing what you are already doing and that you want to get engaged with the project, and that.
And then you have to write a trip report about what you did and who you saw and what you learned while you were there. And that turns into a blog post on the Foundation's website.
Right. And that's the good way to, not only listen to the talks that people are doing, but also approach people, say hello and say hi, and I'm trying to get involved. Can I get you some work done, or can I get some tips for you how to get involved, or how should I approach this project? There's a lot of things that are better done directly from person to person that are not so well, or take more time over email, or
they can all be done without that if that's not available. Yeah. I think the big thing for a lot of people is they want to contribute, but they don't know where to start. Really, what you have to do is find the bit that you're most interested and passionate about, because, solving these problems can sometimes be kind of, annoying, and you have to struggle through it sometimes, and it can push back a lot sometimes. And so if it's something you're really interested in and passionate about, it's easier to keep going. And it makes it not harder to give up, but it removes some of the incentive, right? You're really interested in it.
Yeah, you want to get it done or want to get that problem solved.
Yes, or in particular, how most open source stuff gets actually done is somebody scratching their own itch. There's something that's really nagging you or bugging you or wish this was easier or wish this was different. Starting there instead of necessarily, where does BSD need help? It's like, well, it needs help in making it a better system for you and people like you. And you're more likely to do more work if it's of interest to you and helping you than if it was just, something that you weren't that interested in, but were doing anyway. It's your volunteer time. So it's something you have to, it has to be something you care about in order for you to keep doing it long term.
Right. And if you want to know what kind of persons are working in a specific area of the system, then you should make a habit of trying to read the commit messages.
Well, you can look at them
just
after
by reading
the fact, right? If you go to
the description.
But if you go to
you can find the people that are working in that area or what kind of problems are currently being worked on. And then you can see in the source tree what previous people were working on a specific area or a similar source file that you are looking at.
If you go to svnweb.freebsd.org and browse to the directory where the code you're interested in is and switch to the log view, you can see, the last 10, 20 people that made changes there and read the description of what they did and find the person that seems interested. Also, there's the annotate or blame mode in SVN. If it's a bug in a certain line, you can find out who last modified that line and might be the right person to talk to.
Yep. And again, if your first contact doesn't get a reply, don't be disheartened by that.
Definitely look at the mailing list rather than mailing individual people because, sometimes people are unavailable for months at a time.
Yep. It doesn't mean that they are bad people. They're just overloaded with work and might reply a couple of days later or when your next email is, but don't bombard them with email. Why didn't you respond to me? Why didn't you respond to me? Just be patient with people and try to find other things to get their attention.
Okay. So that's all we have for you this week on BSD Now. Yes, please make sure to send us more feedback, whether it's questions or answers to things that we've asked or comments about the show.
Little stories, how you use BSD.
Yep. We'd love to hear from you about pretty much anything so that we could talk about it on the show. Or if there's something you'd like us to do different or some way you'd like to make the show better, do let us know. Email feedback@bsdnow.tv. All right. We will see you next week. So that'll be next week.